today's lesson, we are going to look at Mathematics 2611 Linear Algebra. We are going to look at eigenvalues, lesson 102. Let us start. There is lesson 101 of this topic, where we look at necessary steps to find the eigenvalues. But in lesson 101, we're using a 2x2 matrix. Now in this lesson, we're going to look at a 3x3 matrix. It's very important that you watch lesson 101 for you to get the basics. And then you watch this one for practice questions purposes. Now remember, the first step, we need to find our characteristic matrix, which is defined by this. So our matrix A is 0 0 0 1 1 1 1 is 0 1, and then minus lambda. Our identity matrix is 1 0 0 0 1 0 0 0 1. Actually, let us multiply this. So we have lambda 0 0 0 lambda 0 0 0 lambda. Then from here, 0 minus lambda, it's negative lambda. 1 minus 0 is 1. 1 minus 0 is 1. 0 minus 0 is 0. 1 minus lambda is 1 minus lambda. 0 minus 0 is 0. 0 minus 0 is 0. 1 minus 0 is 1. And then 1 minus lambda, we are actually here. 1 minus lambda is 1 minus lambda. This is the characteristic matrix, and then we need to find the determinant of our characteristic matrix. We know that to find the determinant of a 3x3 matrix, we need to follow this pattern, provided we focus on the first row, first column, which will be the first element, which is this one, negative lambda. So looking at negative lambda as our first element from the first row, first column, we have negative lambda. We know that we ignore this column and this row to produce this small 2x2 matrix. Then we write it here. 1 minus lambda 0 1 1 minus lambda. Remember, the pattern is plus minus plus. So focusing on the second row, the first row, second column, we have this element, and then we ignore, or we take out first row, second column, and then we have this matrix. Then remember, the pattern says the second row, it will be negative, so you're going to put negative 1. Look at the remaining 2x2 matrix. 0 0 0 1 minus lambda. Then we have plus. Our last element is this one. We ignore this row and column to produce this. So we have positive 1 we have 0, 1 minus lambda, 0, 1. Then from here we can work out the determinant. We have determinant of a 2 by 2 matrix. We simply multiply the diagonal and then minus the second diagonals. So we have these diagonals, which is 1 minus diagonal, 1 minus lambda multiplied by 1 minus lambda, minus 1 multiplied by 0, it's 0, minus 1, 0 multiplied by this, we are going to have 0, minus 0 multiplied by 0, it's 0, plus 1 multiplied by 0, it's 0, minus 0 multiplied by 1 minus lambda, it's 0. So we can simply distribute this. Then we are going to have 1 minus lambda, 1 minus lambda. Know that this will simply be 0. So this is the characteristic polynomial. Now to find the characteristic equation, we simply let the determinant to be 0. Then we have 0 is equals to negative 1 minus this, and then dividing by 0 both sides, negative 1, we are going to have this is the characteristic equation. And then to find our eigenvalues, we have you can see that our first eigenvalue will be 0. Our second eigenvalue will be positive 1. Now you can see that positive 1 is the algebraic multiplicity of this eigenvalue. Well, we can see that it appears 2 times. Now that's it for this lesson video. This is Wahula SJ. Thank you very much.